Oh, damn.
So I've been begging for it forever. So I have these two microphones and this and so I can ride them on and these on the wireless.
Yeah.
So it'll be
What commercial did we say for you today?
Just
any video production, Joseph? Okay. Okay.
You wouldn't have tried that. So
trying to figure out the delay. 15 seconds for your words.
Yeah. Okay. Oh, okay.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, And now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Welcome guys to Charlotte IoT. I'm stoked to see another full house. Our group's been doing like amazing. We've got almost 1,200 people at 1165, and every day we add a new person, and so this group is just like growing and becoming more and more incredible. And we do technical presentations, we do workshops, we do hackathons, and our group is all about learning, and it's all run by volunteers, and we have a great time. And the reason this group is amazing is this board here is just like filled with the best people in Charlotte, maybe even the world, on IoT. Yeah, this group is like amazing. Graham, he was like out of town the other month, and I forgot like how much he does for us. He does all the facilities. He orders pizza. He helps test things, and really good. Rob, he's our hands-on lab coordinator, and he does like really epic content for labs. We've done a lot of them, and he's got some really great things we're doing at Discovery Place. I'll talk about that when we talk about the Maker Faire, but really thankful for everything Rob does. And Joseph, he's doing our streaming of videos. He's helping out with making logos. He's making t-shirts. He's doing all kinds of things for the Maker Faire, and any odd job he's like incredible on. And we didn't even know we needed video streaming, and he brought that to us. And he also does video streaming on the side, or not on the side. He's like had a company that does video streaming. And so if you guys need to make a YouTube channel or need help making like really cool intros and things like that, make sure to talk to him because he can help everybody. He's awesome. Mike, he's our swag coordinator, and he's the reason why we always have tons of stuff to give away every month except for this month. And he hooked us up with Hackster, and Hackster has just been like totally amazing. I've got a separate slide on Hackster, but especially this month they did something special for us that I'll say for when we get there. Christoph, he's our large event coordinator, and the Maker Faire is coming up as our next large event, and we've got sign-up sheets, we've got all kinds of things going on, so we're very thankful for everything he does. Glenn's our social media wizard, and he's one of the reasons why we keep on accelerating our growth, and he's made some slideshows and a video for tonight too. So Glenn, can't thank you enough. And Jeremy, our civic hackathon leader, just really doing incredible things. Like I could speak 10 minutes on each person on how incredible everyone is. And the civic hackathon in particular, I'm really like proud of, and Jeremy's done some amazing things that we'll talk about in just a little bit. Our YouTube channel is really easy to remember because it's just YouTube with Charlotte IoT. And after tonight, you can come home and you can watch this talk like over and over again. So it's like really good. If there's something you're stuck on, just go to YouTube. And if it's something you want to tell your friends about, they can watch it. And we're doing a lot with social media. Slack, we've got lots of channels in Slack, and Mike's been really good with adding people to Slack. You on Meetup, when you enter in your email after your profile information, enter your email and your Twitter, then Mike will give you an invite to Slack, and anyone in our group can give you an invite to Slack, but the trick is they have to have your email account. And thank you, Mike, for getting all that done. Our sponsors tonight, I've got a slide on each of them, but let me go straight into Snap. And Graham, can you come down and tell us about the jobs you guys have?
Yeah, so how many first timers? Oh, good. Less. It's good that we get repeat people. So I work for Snap AV. Snap AV, we're here in this building here. If you're familiar with our company, we are a manufacturer of audio video equipment. And I run an IoT platform called Oversee, and that allows our dealers who are your AV dealers of the industry to be able to remotely manage all of the IP-enabled devices that we manufacture and make. So we have about 750,000 devices connected to our cloud, and I have 2 open positions. So if you're a server engineer and are looking to work on a dynamic server environment with IoT, then come see me. Or we're also looking for a DevOps engineer. If you're a Linux master, great, that'd be good too. So, but welcome everyone. Thanks for coming tonight.
Yeah, staff has been like an incredible sponsor of the group. Anything we ask for, they always give us. They give us the room when we do special events. They don't care, or they maybe care because they give us everything. So
I even let you shoot fire.
they are like one of the few places that let us play with fire. And Hackster IO is incredible, especially this month. We've got the Maker Faire, and we've got a lab that we're doing at the Maker Faire. And the parts for the lab cost more than our normal $200. They gave us discounts and got the price down to $300. And then they just up and paid for the whole thing for the Maker Faire. For the what are the kits called, Rob?
It's the Fruit Circuit Playground Express.
Yeah, so if you guys know intro people who want to learn about how to make cool things that are connected or cool things with circuits, come to Discovery Place at the Maker Faire. I'm going to trip on this and break something, but it's going to be awesome. And before I forget, at the Maker Faire, we also had sponsorship with Microsoft Store. They're giving us 15 Surfaces during the event so that we didn't have to worry about trying to get laptops and borrow, because in the past we've tried to borrow people's laptops and it's really hard to get 15 of them, and so they just made it easy, and plus it's on a really cool device, and so Microsoft and Hackster have really helped us out for the Maker Faire. And a little commercial on my company, Logical Advantage. We started it 14 years ago. I'm one of the co-founders, and we do really epic things. We just did a talk last month on a project we did for a smart factory, where each one of these spindles, we put a microcontroller that's measuring the uptime of the spindles and posting all the data into Azure. And once the data's in Azure, you can do all kinds of really cool things, report on like the whole plant, what's up, what's down in any given time, and really help their efficiencies. Really great stuff. We've done all kinds of really fun projects, smart city projects. We're tracking millions of carts in hundreds of cities. And things from racing. I usually wear a tweet shirt that if you tweet me, it lights up. Didn't bring it this time. And Jeremy's going to talk about our Civic Hackathon. And this I'm so proud of. I don't want to steal your thunder. I'll let you go.
No, I mean it's been really awesome. I can't thank Dan enough. It's Ben here. Ben is kind of our inspiration to get the whole thing started. Mark's been awesome to do some work for us. And I mean, just everybody who's been at the hackathons has been just amazing. We did our first installation 2 weeks ago Monday, and you know, it just kind of melts your heart when you provide somebody something so simple, and you know, you just know how happy they are, and you can see it, and it's just it really, you know, just lifts you up. We're doing another hackathon November 4th. We're doing it at Lending Tree in Ballantyne. If you needed the address, let me know.
It'll be up on Meetup too. I'll put it on hopefully tomorrow.
And then, yeah, and it should be pretty awesome. We'll have free pizza and do some fun stuff. And
you need to put this slideshow up?
Yeah, so there's a slideshow.
Which one do you want first?
This slide.
All right.
So this is the Queen's Meetup, and I can't say enough how much Ben kind of inspired getting this going. And you know, Dan put a lot of this. It was mostly you, Dan, who put a lot of this together.
Everyone,
yeah, kind of everybody, and it was a great opportunity for us to kind of practice on what one of these should be and what we want to do. We made a lot of great progress. We learned a lot from it. We kind of figured out what kind of did work and what didn't, and then came to Lending Tree. I kind of took over the project a little bit because it wasn't moving very fast, so I was like, let's do this. Found a location, put together an agenda, and just let awesome people come and help us figure out solutions. And that was amazing. And then the best part was we went out to Sean's 2 weeks ago, 2 weeks and a day ago. Just got to work with him, and we put in a voice controlled light, a voice controlled fan, and then we set up his TV so that he can voice control turning his TV on and off. You can see, I mean, this is you can see just how happy he was. Anyway, so I couldn't play the video. I pretty much the same thing I just said, actually, I think, but so.
So I'm Jeremy Prophet. I'm on the board of Charlotte IoT. I'm on the Civic Hackathons, and I can't tell you how much of a pleasure it is. We're here tonight with Sean, and Sean, we've been able to give you the ability to control a fan, a light, be able to change the channels on the TV, turn the TV on and off, change the volume, listen to some Bible verses if you want to on the Alexa. How does that feel? I'm and this is why we do it. To give people freedoms that they didn't have. Sean is just an amazing person, and now he's going to be able to watch TV like everyone else, channel surf like everyone else, and enjoy life a little bit better. And also, it's good for everybody. And for myself, I think it's pushing my bounds of my technical knowledge of this the home automation. I've been able to write a lot of things that I wouldn't have been able to otherwise. Dan kind of tricked me into doing some stuff that I wasn't really comfortable with, but have really enjoyed doing and learning about. We get to help people like Sean. I just don't know that there's anything better.
So, and the one thing that the video doesn't see is that Sean has an electrically controlled recliner chair, yeah. And so Dan is underneath the recliner chair, like looking at all the electronics. Because the next thing we want to do is put Alexa controls on the wheelchair, or on the chair itself. And then we've got some ideas for his wheelchair at the facility he goes to. We've got some great ideas on how to put some automation into that, so we can have some more freedoms there as well. So it's been pretty awesome just working with everybody. And as you can see, it's an amazing experience. So if you want to join something that's really fun, that's really changing people's lives, come help us at the Hackathon, November 4th at Leningrad.
It was epic. I mean, just the smile shone on his face was just priceless. It's really amazing. And can't thank you enough, Jeremy, for leading the project and getting stuff to where we could actually deliver it. He also gave some of his own stuff, like hubs and a TV. I mean, he donated a lot of stuff to Sean with his own stash of stuff. So thank you, Jeremy. All right, so the next huge thing coming up is the Maker Faire, and it's on the 14th. And this year, I'm kind of stoked. Discovery Place is allowing fire at the fair, and so we're bringing the Alexa-controlled monster that I made for Halloween last year. It's a 12-foot monster. You talk to it, and it spits 6 feet of fire out its face. So that'll be super fun. And Mark and I have been working on a smoke machine that blows bubbles of fog that hit the ground, and the bubbles pop and make these awesome fogs. So that'll be there. But we need more things at the Maker Faire. We've got 3 tables, and I've got to things so we can have really cool things at our tables. I want to pass this around. If you guys could sign up for bringing really cool projects, that'd be awesome. And Jeremy has made this T-shirt. So if you help us volunteer, you get a really cool T-shirt. And what color are the shirts? Joseph, I'm sorry. What color are the shirts?
It's like a charcoal heather and a charcoal or a heather navy. So it's like a poly blend polyester. It's really soft.
Really soft, really cool shirts. And we've got this really cool banner we're going to put in front of our tables. This will be really nice at the event. And we're looking for like tons of volunteers. And last meeting we asked for people to sign up, and I think that people might have thought that it was like the roll call for the meeting because like everybody signed up. And I don't know if that was intentional or not, but we've got a new sign-up sheet. So even if you signed up last time, please sign up again because this sign-up sheet is Christoph made it, and it's way better than the last one because it has like time slots of the day, so we can coordinate who's at what booth. Different times in the day. We also have the lab, and we're doing 2 labs. It's the same lab done twice, and the lab's from 1 to 3, and Rob will need help with that.
Maybe change that. I was thinking maybe do 3 or 4.
3 or 4?
Like
exciting.
Shorter time periods, but throughout the same period.
Okay, so there's...
Essentially, if you can volunteer for the whole 2-hour slot, we'll take it.
If you can volunteer for the lab, then write the times that you would be available for that, and that would be helpful on this sign-up sheet so Rob can help coordinate and plan. And Christoph was sending emails out to everyone who signs up to do the planning on this. And you want to say a little bit about how cool the lab is, or we talked?
Yeah, so we're basically kind of taking a little bit of a lesson that we learned last year, but a lot of the folks that came by to kind of check out our lab last year were extremely novice. They hadn't really done anything before at all. So instead of kind of overwhelming them with, last year I think it was, we did the Intel Edison and the Brood Box growth kits. We're actually just going to take it completely back and just work with the Circuit Playground, which is a development board that has a whole bunch of cool stuff built into it already, like temperature sensors, 3-axis accelerometer, 10 neopixels. It's got an IR blaster receiver, and essentially what we're going to do is use the MakeCode interface, which is a block programming language, so that people that have potentially never done anything before don't feel like there's a high barrier to entry getting into working with these types of microcontrollers.
Awesome. So a lot of really cool things going on at the Maker Faire. And the next really cool thing is Geek Fest. And Joseph knows more about the Geek Fest, I think, than anyone. And I didn't ask you, but can you tell us a little bit about what's going on at the Geek Fest? And
so in short, it's CPCC does a makeshift Maker Faire. It was originally for the school to show off the technology that the school does to other students, and it's at the Levine campus. Then they expanded it to high school students, then they expanded it to middle school students. And so if you've ever been to the Levine campus, it's fairly large, but they clear out about a dozen classrooms, and the entire atrium, which is about the length of a small mall, they just have tables set up down the hallway, and in the classrooms there are 50-minute sessions. So every 50 minutes from sometime in the morning to sometime in the early afternoon, they're teaching stuff like how to build a web server out of a Raspberry Pi, how to do stop motion animation, First Robotics is there, and lots of businesses, because CPCC is the nation's leader in workforce development. So there's all these companies that come down to recruit, but also to show what awesome stuff their companies do. And at CPCC, we do a lot of innovation in IT. I just did a Raspberry Pi and Arduino Tinkering 101 presentation, and so they found out about Charlotte IoT and the Civic Hackathon, and they ended up giving us a whole room for, instead of only being in there for an hour and then somebody else being, we have our own room that we can do 1-hour workshops throughout the day, and then have tables and just, show middle school, high school, and college people what is in store for them after school is done. I think that's everything.
Can Dad bring fire?
Yeah, can I bring fire?
I don't know. I don't. So usually they crowd them out, but we're going to cut it off after like 20 or so people for the workshops. But it's a great event that's free that you can just walk through the campus and see other groups. So it's kind of like a mini Maker Faire.
I've got a sign-up sheet if you want to help us out with the Geek Fest, and you don't have to stay for the whole time. And if you sign up on this, then one of our board members will contact you and see what would you be available for and what do you want to help with. I know Jeremy is thinking of doing a talk on how to interview, or what's the talk on, Jeremy?
So I'm trying to get my CTO to come out and do a talk about what it takes to get a job at a technology company, which I think would just be cool because our CTO does programs on the weekend, so it's kind of an interesting guy.
Sweet.
And then whatever else Joseph wants me to show off or do for training or whatever, we'll have out there.
So if you guys have ideas, yes.
Yeah, just to add the Geek Fest, so I've presented the last 2 years, and the kids are extremely engaged, and there's like a ton. So it's yeah, so they're extremely engaged. There's like it's constant attendance. So if you guys got free time, I can't recommend this one enough.
So I don't know, Rob, if you have availability. It's on the 9th, but not to put you on the spot, but it'd be really cool to have those block kits, the Adafruit ones, playground for that too.
And if you have a company in Charlotte, like the biggest problem that companies face is talent pool. And CPCC has created this amazing pipeline to the talent pool through their 9 locations. There's like 6 campuses. So if you are a piece of a business or you run a business in Charlotte and you're trying to get good talent, and I don't mean just welding, like the folks that come out of there are, they have IoT classes, and I mean it's amazing the quality of student that comes out of CPCC. And even if you don't run a business, if you want to appear really awesome to your HR and your headhunters and your CTOs and stuff in your company, the folks who run it are still looking for people to do either workshops or to run booths. They're going to cut it off real soon, but you could have a table out there of your business and just inspire the next generation and inspire students who are hungry. Like they choose this as their one field trip for the year. Instead of going to the Mint Museum, they decide to go to CP for the Geek Fest.
Sweet.
Because this is the career they all want to go into. So they're starving to walk around and they have no idea what careers are available and what's out there until they go to something like this, and then they see Industry 4.0 or that, and it really, you see that little light bulb go off. Now, there is a lot of students there. I just want to throw that out there.
It's good.
There's a lot of people there.
Awesome. Thank you, Jess. And you guys won't want to miss next month. I think the lightning talks are one of my favorite talks that we do. And we've got some killer ones next month. And sorry for surprising you, Mark. I forgot to ask you. But Mark and I have been doing this really cool project. And it's making fog. And Mark's like a Jedi at making 3D printed things that we can control. And so that's the last one we're going to talk about, but sorry for mentioning it first. David is going to talk about Influx. It's a database made for streaming analytics. And Rob's going to talk about HoloLens. And Jeremy has built some really cool things for the hackathon. Started off for the hackathon, but now it can be for like anything for connecting particle photons to the smart home skills with Alexa that are really cool. And you're doing a talk on Thursday. Where's that at, Jeremy?
So the bot meetup, which is at the
Music Factory.
Yeah, the Music Factory. It's from 6 to about 8, and we're going to be doing a full. We're going to talk about actually building an Amazon Alexa home automation application, and then we'll go from there into what I've written, and then how that works, and then go through like the certification process and everything, which is honestly a real pain in the ass. So, and just kind of what you can expect if you want to do that process, and kind of this lightning talk will be just the photon echo bridge part, but that will actually be the whole like publishing an Alexa app and
That's sweet.
Scaling the whole bit. So, and we're gonna actually Joseph's gonna report it for us. So I think it'll probably be up on the Charlotte IoT page too.
Yeah, I can't wait for the lightning talk, so I'll definitely be there on Thursday. That's going to be awesome. Epic also, Hewlett-Packard, he's the chief enterprise architect for a big data platform that Hewlett-Packard owns, and he's going to talk about IoT, and it should be really good. So we've got a lot of things in the queue of Charlotte IoT that's just like amazing stuff. And finally, the main event, Bhakthi?
Yes.
Bhakthi. He's going to talk about being a Jedi, and Bhakthi has recently moved to Charlotte. Where are you from?
From New York.
From New York. And he's a Microsoft MVP and just an amazing person. We met up at a couple of Microsoft events and just hit it off, and he told me about this Jedi project, and it's like, oh, heaven, a bunch of like imagine what we could do with this technology for helping paraplegics and other things too. So I'm hoping we can incorporate what we learned from you today to help other people, maybe in our hackathons if it's that mature. But can't wait to see what you have to tell us. Thank you.
All right, thank you.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.
Thank you very much for attending this session. Thank you very much, Dan, and all the sponsors of the event. So today, actually, I'm going to talk about it's a quite it's not very new, but it's quite new topic. It's about how to integrate your thoughts and brain waves, the brain activities with physical devices, right? How you can use your brain activities to actually control remote devices. That's the topic that I'm going to talk about. So this is me. I don't have to explain. Dan already gave an introduction, so I'll skip this. But I'm on Twitter. If you want, you can tweet me, and if you want, you can email me. So the agenda is we'll talk about the brain waves and how we can capture them and how we can use them, and then next one is the introducing how we can actually interface your brain activities with physical devices. Right, without just having your brain waves would not do anything. You can just think and that's it. Right? But what if we can actually think of something and then get something done with that thought. That's what I'm going to try and show you. And for the second part, just a very high-level introduction to the Azure platform, the IoT, Azure IoT, because that's what I'm going to use to remotely control something, right? So I'm going to use my MindWave headset and control some devices remotely connected to the IoT hub. That's the demo. But before that, I will be doing some couple of demos. I would probably need some help, some volunteers to actually try certain things wearing this headset. So let's see. I mean, it's going to be really fun. So before we start, I'm not a neurologist or a neuroscientist, right? That's the disclaimer. So if you are a neuroscientist and you know all about neuroscience, please don't ask me about neuroscience questions because I know nothing about. I know enough to get things done, how to capture and the basic functionality and how the brain actually works, but other than that, I have no clue actually the cell structure or how actually the neurons work and so on, right? But just for the completeness of the slide, so what are brainwaves and how do we capture them? The root of all our thoughts and emotions and behaviors is the communication between neurons within our brains, right? We have millions and millions of neurons in our brain. So whenever we think something, what happens is it generates electrical signals in neurons, and then the electrical signals pass through neurons. So when excuse me. So when neurons are passing through, the electrical signals are passing through the neurons, it actually generates electrical signals, right? Magnetic signals. So if you know electricity or electronics, when there is a current passing through a wire, it generates electromagnetic waves around that wire, right? It's the same thing. Same thing happening in your brain. Like, the electrical signals passing through each neuron, it will generate electrical signals, but they're very, very weak, right? Usually we don't even know whether there is an electrical field around you. But I think maybe about 60, 70 years ago, one guy came up, a doctor who actually invented this EEG device, which was able to capture the brain signals and amplify the signals, and he was able to see the actual brain waves, right? And not seeing like looking at it, but interpret the brain waves into electronic form, right? So that's very high level. That's how it works, and I'm sure you all must have seen. Right now, the brain activity is captured through the attaching a lot of probes into your head. Like if you go to a hospital, like especially in trauma centers, you see people have like the probes stuck into your head, and it's all the wires going through some big machine, and then the doctors see the graphs, right? That's EEG. But you wouldn't want, unless you are sick, you don't want to have all these probes, you know. So, and especially with like very expensive machines, you don't want to carry them around, right? They're very expensive, and you and me, we can't have them, right? They're very expensive. So because of that, the inventors, they wanted to actually find a way to capture these electronic signals and try to make use of them instead of you being in the hospital and hooked up into a machine. Now we have the capability of actually having a wearable device which actually collects actually collects all the activity going on around your head, right? So that's actually a breakthrough, because those days only way that we could capture EEG was through a huge machine, but now we have simple devices, and also the most important thing is they are very, very cheap, right? So I think that the cheapest EEG machine and hospitals are like 100,000, more than 100,000. Right? They are really, really expensive and they are really bulky. But these guys, these are very, very cheap. I would say like $200, $300, right? But they are accurate enough so that you can actually use them to do fun stuff, right? Not just fun stuff. Where Dan was mentioning that they were doing this project for Sean, right?
Yeah.
Yeah. So those activities actually voice activated, right? Mm-hmm. But I used to help a research team at Rutgers, because that's where I used to live. I used to live in New Jersey, and one of my friends who was a neuroscientist and a researcher at Rutgers, they were doing like really crazy experiments for people locked-in syndrome, right? You know, locked-in syndrome. Your body is not functioning at all, but your brain is actually working. Right? You are just like the patient is just in vegetation state. The brain is working perfectly, but no problem with the brain, but their motor functionality is lost, right? So what if we can have this technology and by thinking of maybe turning on a switch or turning on heating or something, if someone can turn the heating on just by thinking, or maybe turning the television on just by thinking, right? That would be really cool. So those are the things that actually we can do with these kind of simple devices, right? To do that kind of thing, you can't be hooked up into a huge EEG machine, right? It has to be very lightweight. It has to be affordable. That's the main thing. It has to be cheap enough for people to buy them, right? So that's what I'm trying to focus on. How we can actually capture the brain activity and for very less amount of money, and then try to get things done. So before we go into all these gadgets, we need to understand what type of brain activities we have, right? So once we know a little bit of the structure of the brain activities, then it's easier for us to convert those electrical signals into whatever the form we want, right? So in general, in very high level, there are 5 different type of brain activities going on in our brain, right? These are very high level, but you can actually break them down into more fine details, but very high level, there are 5 different types. So we have something called delta waves. Delta waves are more prevalent when you are actually in a deep meditation state, or if you are in a dreamless sleep. There will be a lot of delta waves will be generated, right? And for theta waves, if you are in deep if you are meditating very deeply, there will be a lot of theta frequencies will be generated, and so on, right? So we had alpha is mainly if you are very calm and very alert, then you will see a lot of alpha waves being generated. Again, if you are solving a problem and focusing on, if you are solving a math problem or solving something, a complex problem, we will see a lot of beta bands, waves being generated, right? So these are actually already scientists have decided these waves and bands, and by looking at the wave bands, we can actually determine what these people are thinking. I mean, what's the state of the mind, right? So I already spoke about this, right? See, usually this is what you see. So many wires attached to your head, and the patient has to be in the hospital and so on. And these are very expensive, and the devices are stationary. You can't carry them around. So, and next I spoke about this one, the wearable EEG devices, right? So right now we have, there are so many, but in my experience, there are about 3 different companies making these wearable EEG devices, right? One is called Emotive, and the other one is Neuroscience, and this one is OpenBCI. It's an open source project, but this concept is really interesting. This you know, the helmet, you can actually 3D print it, right? They will give you the plan, and you can 3D print. If you have a printer, then the cost will be very, very low, right? All you have to buy is the set of sensors, and they will actually give you the 3D print, the plan, right? You can 3D print it. So those are the things that are actually happening. It's really interesting, really interesting how companies are trying to get the cost down, right? So that these are actually available for general public. So let's do a demo, right? Can I get a volunteer? You want to come and help me out?
It doesn't work, I blame your mother.
Okay, so let's see.
I'm sure that can go wrong.
Okay, so let's clean this up, and then you can wear this. So this device is actually made by Neuroscience, right? This, I think it's about $200. And here we have the sensor. So this part is the sensor, right? So the reason that these guys have the sensor in the front is this is called one-channel device, right? So it captures only mainly alpha waves. So what happens is, when you actually think, when you concentrate, there are a lot of waves being generated around your forehead, right? And also around your left ear. So that's why these guys are actually focusing on capturing your attention and the meditation, right? The standard is 20. It's called 2030 or something. So the industry standard is to capture capture the brain waves using 20 sensors, right? That's the research grade devices have that configuration. But the more sensors you have, the more expensive it's going to get, right? So these guys, what they do, they just try to capture the activity around your forehead and your left ear, and try to determine your attention level and the meditation level, right? So let's get this attached to your head. Okay, I'm going to put this. Is it touching your forehead?
Yeah.
Yeah. And I'm going to put this. Okay, let's see if we can. Okay. Can you come over here? I want to see. Okay, it's actually should be connected. Says it's connected. Yeah, it actually connects through Bluetooth, and okay, let's go to a Bluetooth and see what's going on. It's actually connected.
This is a time for a dad to make a joke that there's nothing. It's not okay.
No, it's not his fault. It's not his fault. He's thinking. He's concentrating, but his brain waves are not actually getting to the computer now. So let's see. Disconnect. Let's. Oh, I think I know what's going on. Let's close everything down. It's not hurting, right?
I know.
No? Okay.
The magnetic fields don't have a big range.
And Doc Brown was 20 years ahead of his time.
Okay, let's try it again. No, it's not connecting. Let's turn this off. No, it's maybe it's the Bluetooth, I guess. It says it's connected, but
There it goes.
okay now. Oh no. It's actually connected, but again it failed.
That's cool.
Oh, see, it's
Pretend that's it.
retrying. Yeah, it's retrying the connection, but I don't know why it's. It is actually connected. Can you blink? Blink? No. Okay, let's try the other one. Okay, let's try. Okay, let's try the other one then. Oh. Is it touching your skin here?
Yeah.
This side?
Kind of.
Is it too tight?
No.
No? Okay. This guy is working. So see now that okay. See the sensors blinking. So that means it's actually capturing the waves, right? So let's see. Let's see. Can you blink? And when you blink, see it actually captures the blink. You can look at it. Blink. Okay. Yeah. See it has a slight delay, but. Can you wink and frown? Smile? Yeah. Okay. So that's.
How is it knowing he's blinking? Is it brain activity or?
Yeah. So when you blink, it generates a different signal. Like it's an interruption. Right, so you have the normal brain activities going on, and when you blink, it's an interruption to the normal the normal brain waves, right? And when you wink the right eye, then it's a different disruption.
Wow.
And if you blink with both eyes, then it's a different disruption. And also with blinks, it will generate different activities. I mean, the different waveforms. So that captures that waveform and are you blinking?
Yeah.
That's how it captures. So let's see the performance metrics. Now, do me a favor. Think about something like really focus on something, right? And then you should be able to see. You can look at that. You can look at the screen, right? Think about like really hard on something, and you should see your the focus. Focus is like I think it's this one. This is the focus, so it should go up. Signal is noisy. Why signal is noisy? Or maybe it's not touching the reference. Oh, it's yeah. You know what? Your the not the glasses. The arm is actually blocking the reference here. Yeah, it's a. So.
Unfortunately, if you're a room full of engineers, that's exactly
What's that?
Oh, we're suggesting you could make it more efficient by shaving his head.
Let's restart this. It says signal is noisy. I don't know why signal is noisy. Maybe it's this Raspberry Pi. I don't know what's causing the noise. And also you can. So the interesting thing is here. You can actually generate mental commands, right? So here, right in this one, I train for myself. We can. What you can do is. You can take that off if you want, if it is uncomfortable. So you can sit. Thank you. Thank you very much. So actually, this is really interesting, right? So this device has the capability of training a certain mental commands, right? So. Right now, I have actually trained push, lift, left, and right. So what it does is it actually gives you the option of training the model. It's actually creating a model, right? So you put this on, and then say I will select left. And I will, let's see if it is actually recording. Yeah, you have to turn it on. So as soon as it I think what happened when you wore this, it was not touching the skin here, the back of your head, the back of your ear. So that's the reference point. That's where the most activity is happening. So it actually creates a reference point from this signal, and everything is captured based on the reference point. Right. So if the reference point is not actually the signals at the reference point is not captured, everything goes haywire. Right. So right now it's actually, for me, it's actually then now it's touching. So that's why it's generating some signal, but it says, yeah, signal okay. So what this device has is it's really cool. You can train different commands. You can train up to 4 commands, right? So right now I can first thing is the natural state. So it has to have a baseline, right? What is your natural state? So we train a model. It's inside this software. It trains a model to capture the natural set of brain waves when you are not thinking, or when you are not focusing, or when you are not meditating. It will capture that set of brain waves and create a baseline, right? And then you can train push, right? I can select. I think I can select 4 commands out of 10. So I click push, I select push, and then click start training. And it will ask if I want to record that brain activity when I'm actually thinking about pushing something, right? So you saw that it's actually the animation is actually it mimics that you are pushing something, right? So when you see that, you think about that you are pushing something. So at that time, a certain pattern is generated. So this actually captures that certain pattern. And when you are thinking about you are moving something to your right, a different pattern is generated. So it actually captures that pattern. And if you are thinking about moving something to your left, it generates a different pattern, right? So similarly, you can train different commands. It will capture the wave signal corresponding to that particular command, right? So when you go to actually use it, and if you think about moving something to your right, it tries to map with the trained patterns to identify what actually I'm thinking about, what command I'm thinking about. Did you get that? Or mm-hmm. Yeah. So if you look at it, you can right now this is because this is not the expensive one, right? So, but if you actually use the expensive device, you can actually train up to come on. Let's see. You can train up to I think you can train up to 4 commands plus neutral. But if you they have another device which is little expensive, you can actually train 8 commands, right? You train the commands, and then when you think about after you training the model, you will think about moving left or right or whatever. Then the device will tell, okay, what's that command that you are thinking of, right? So what are the use cases that actually we can make use of these commands, right? For example, suppose that person that Sean, right? Sean actually can talk, but for example, a person like who's this scientist? Stephen Hawking. He cannot talk, right? If he can get hold of a unit something like this, he can train a set of commands, right? And the commands can be converted into a motor or to his wheelchair, and then he can actually using the mental commands, he can move his wheelchair, right? Or those commands can be, I mean, it doesn't have to be push or right turn or left turn. It can be mapped to any command, right? So depending on the command, you can decide whether to turn a light on, whether you turn the heating on, or anything. So it's just simply a matter of mapping those activities into a real world scenario, right? So that's very powerful. So this is mainly for people who actually cannot, who don't have motor skills.
So is the pattern matching all actually done in the device?
Yeah, it's actually it's done in the software itself. It's in the so different people can have different profiles. So if you want to train a model, and I create a profile for you, and all my training data will be stored under your profile, right? So
so is the 4 versus 8 command limit just marketing?
It's for marketing, yes. Okay. Yeah.
That brings up another interesting question. So does the company give you any internals as to what the raw sensor is giving out?
Yes.
Do you have the ability to hack that yourself?
You don't have to hack. There is a SDK, right? So this is fancy marketing. 4 commands is marketing, right? They provide the SDK. SDK, you get all the raw data. You get alpha, beta, gamma, delta, all the information, right? So you can come up with an algorithm where you actually have if the attention is more than like 50%, then it maps to some command. If it is between 50 and 60, then it maps to another command, and so on. You can since you have the raw data, you can do whatever you want with that. Right? This is just for fun, right? This software interface actually doesn't have anything. I mean, it's really it's just for fun, but the real power comes with the SDK. You can this connects to through Bluetooth, and the Bluetooth is mapped to a COM port, and you can read the COM port. There is a protocol. Everything is documented for this device. So you can read the COM port and get the packets, and in the packets you will have alpha, beta, gamma, delta, and the blink, and if it is a left blink, right blink, all the information, frown, smile, everything. Right. So I don't know, for some reason the other device is not connecting. I think I know the reason, because both actually competing for the same COM port. So it's both are actually connected through Bluetooth to COM3, and I think the drivers are messing up with each other. Because I installed this one after the other one, so this software is working, but not the other one now. So that's one aspect, right? And so you saw the performance metrics right here. So it actually, using the API, you can actually capture interest, engagement, stress, relaxation, excitement, and focus. And even though this device only shows 6, right? 6 different emotions and states. There is another headset with, I think, 16 sensors. This has 5 sensors. 16 sensor has you can capture a lot of states, different states, right? So when you have those different states, you can map. So here's the thing. I mean, when you capture the state, it's just a number, right? It's a number between you. I think for this device, it's number between 1 and 0 for each state. So if you are like really focusing on something, your focus will give you like number close to 90 or 95 or something like that, right? So you can actually turn that into some command. We can write a program to say, okay, if the attention is more than 90, then do this. If the attention is between 75 and 90, then do this, and so on, right? So since you have the raw data, you can actually convert that into another form, which are commands. Okay, let's try the other one again. I hate to give up on that because it has a really nice interface actually, even though it has one channel. Oh, why? Let's try it again. Yeah, it's saying that it's connected, but I don't know. It's for some reason it's not connecting. If it is connected, you should see the actual brain waves in here, alpha, beta, gamma, delta, and so on. You should see it. I don't know, for some reason it's not connecting. It's very disappointing. I mean, when I tried this at home and it worked, when I came here, it's not working. Okay. What's that?
This device too has the SDK and the data sets and everything.
I didn't hear that. I'm sorry.
This device too has.
This one has a C# API.
Okay.
So that's actually now without this connection, I can't show you the next one. So the next one was actually let's disconnect this. It's really disappointed. So the other one that what I talked about, right, converting the raw data into commands. So what I did was in this project, right, it's for Neuroscience, for this guy, right. So I capture that that data through the SDK, right? Let's see. Okay, set progress bar. It has, so it creates a connector, right? So when it creates a connector to the Bluetooth, right? This is actually the SDK, C# API, right? You create a connector which is actually connecting to your Bluetooth, right? And there are some events happening. So connected device connected, connected device found, and let's try running it. Let's see if it. I hate to give up on this. Okay. Let's try it again. So now it's actually scanning for the Bluetooth port. I don't believe that it's actually, it will, oh, it actually worked. Okay, so it will not give me anything because I'm not wearing that. Do you see the the command prompt, right? That's actually connecting to this device, and every time when it sends a packet to the Bluetooth connector, it will capture that packet and try to get the. Okay, so now it's actually I can't actually focus because as soon as I lose my focus, that attention and meditation drops. So let me get my attention level up. Okay. See, so in my program, what I did was I get the attention from 1 to 0. And meditation state from 1 to 0, right? So I converted that number. If the attention value is 60 to 80, then I turn the it sends the information to an IoT hub. Right? Let me connect this Raspberry Pi into my hotspot. And let's see if it. So now it's actually I'm still not sending. It's just generating the signals, and it captures my attention and meditation. I have other information too, but I'm not for this demo. I'm not actually capturing any of those. I just focus on getting the attention and the meditation. Right. So let's hope this gets connected. In order for me to start my Raspberry Pi, I have written a Raspberry Pi program in Node.js which actually connects to the IoT hub. For me to start that, I had to log into that the Raspberry Pi. So let me log into Raspberry Pi. It's a little complicated process because for me to log into Raspberry Pi, my machine and the Pi has to be on the same network. So I'm logging into. Oh, seriously? Okay, good. So let's see what IP it's on. This one actually you can do it.
You want to try again?
Yeah, let me get this running first, and then you can actually. Focusing on something, you can actually turn the switches on in the Raspberry Pi, right? Some relays. Let's try to get that. What's?
It was 1.17.
Okay, so it's, no, my Raspberry Pi is 168.43, 127. Okay, I think we are back in business. Oh, come on. Okay, can you see this? Okay, the red lights, right? So now, okay, let's try it again.
You won't hurt him. Dig it in.
Is it touching your head?
Yeah.
Yeah. Needs to touch your forehead. Okay. So let's try send some data. Where's the other? Is it sending anything? Stop that and restart it. You okay?
Yeah.
So, okay. You should think you have to get, okay. Oh. See, you have to think like really hard and get the, attention.
Yeah.
Yeah, get attention up to S1. Think hard. Like focus on that number, maybe 24. You're actually meditating. See now what? Yeah. So now what I'm doing is, you see the number below here, the actual payload that I'm sending. So this is the payload that I'm sending from this from this device, right? So I'm sending 4 commands, switch 1, switch 2, switch 3, and switch 4, which corresponds to the 4 relays on my Raspberry Pi, right? So I'm sending that information to the IoT hub, and the IoT hub is configured to send that data into Raspberry Pi, right? And the Raspberry Pi, if you look at my Raspberry Pi program, you will see the same commands actually being passed into Raspberry Pi. So this is the Raspberry Pi interface. This is a Node.js program, right? So you see the command 000, it should actually correspond to what we see here. So now it's all switched off, right? All the switches are switched off because, okay. And the relays corresponding to switch 1, switch 2, and so on will be turned on based on what he's thinking. Can you?
Eventually, we can run cars on this.
Oh, I'm sorry, I didn't get that. What's that?
Eventually, we can run cars on this.
Cars?
I'm sorry. Well, I just thought if you're just sitting around, with your image, you can,
Well, an autonomous vehicle with an shoot brake switch.
Oh.
I bet you pick that up really easily.
By the time this gets there, we'll have autonomous cars.
Judging the way a lot of people drive now, they might be doing it already. Yeah, that's a good point. Yeah.
But the thing is,
need to control them and then power them.
yeah, because this. Did you have a question? No. This device is a very, very simple device. It has only one channel, right? So if you have the 16-channel device, which can capture so many raw data, and then you can convert the raw data into different commands, then it should be possible.
So through your experience, I mean, playing with this more, have you been able to train yourself to control the different wave types easier?
This one you cannot train. This is actually just capture the.
Right, but training yourself. I mean, the way you think.
Oh yes, I tried, but I miserably failed because and I tried to do some meditation, and the problem is, right, with meditation, I have to close my eyes, and when I meditate, I can't see what's going on in the screen, right? So as soon as I open my eyes, it drops. So
What's the difference between this device and like the biofeedback devices that like I heard about back in the 80s and the 90s? Is this the same thing? It's just a little more advanced, or is it
it's a little bit more advanced.
Type of measurement,
the biofeedback, some of the biofeedback systems, they actually attach the probes into your skin.
Some here,
Some there, and it actually detects the muscle movement.
Okay.
Right. So this one is not actually. It's nothing. It's actually the brain waves, the brain activity. Actually, I think that's good. Okay. Yeah.
So there's proof, Dan. I know. I can pay attention.
Okay.
So whether it's this one or the previous one, the raw data, is it stored locally or is it in the cloud? Can somebody come back and like use it?
It's actually a really good question. I mean, a lot of people have a lot of concerns about getting this. This is actually very personal, right? But you can actually store data locally. If you want to transfer the data through cloud, then you don't know where it ends up, right? So that's the problem.
Is like the previous headset, is a default option to be stored locally? Or
Can I take it off?
Yeah.
Okay. I'm sorry. Let me take this off. Otherwise, he will he will think what the hell is going on. He's just wearing this. All right. Thank you very much. Sorry.
Well, the one where you can train to move the ball, where we showed push, is the default setting for stored locally or stored in the cloud?
Default is locally. You can choose where to store that.
Because you said, I mean, the analysis, it's not like the analysis of the pattern is going off to the cloud to be done.
It's just going the numbers.
Yeah, you're just using it locally and sending results if you want to.
Yes, exactly.
And sending what it sends.
Exactly. Yes. So in this case, right, in this program that I wrote, I'm not sending any data across the cloud. I'm just converting those numbers locally and then just send the commands to the remote device. Right. In that way, you don't send any brain activity information to the cloud. If you decide, so there are two ways you can think of it, right? If you want to have all the logic in the destination, yes, then you would have to send all the raw data. But if you want to have the logic on your local system, then all you need to send is the commands.
Is it possible to use these devices as input to your computer? Like, for example, the commands that you train, like pushing something, and can you use them as inputs? Like for example, graphic designers use them to zoom in and zoom out. Or
yes.
Because that's like
you can because now since you have with the SDK you have access to the raw data, right? So you can transform. I mean, you can interpret raw data any way you want, right? In this case, the numbers that I got, these guys actually they have a proprietary algorithm to convert all the brain activities into attention and meditation. But since you have raw data, you can transform the raw data into any algorithm you want, right? So at that point, it's not just 4 commands or 8 commands or whatever. You can interpret the raw data any way you want.
So how much variance do you see in the raw data? So let's say you're thinking about the exact same thing, 2 + 2 = 4 over and over again. Do you see that the data coming back is pretty much the same, or how much like?
Yes. Yeah. I mean, it's pretty much same for a given person. It's you can find a pattern, but my 2 + 2 brainwave is very different from your 2 + 2 brainwave. So it's not generic.
So you would have to do some sort of training on a per person basis in order to get the most benefit out of it.
Yes. So at this point, all these devices are very specific to a single profile, right? We can't find a generic pattern across the board.
But sooner or later they'll have like a video clip or a movie that you watch while you're wearing it that absorbs all of those frequencies to calibrate in a 2-minute YouTube video. So imagine a 2-minute YouTube video, you have these colors, these actions, these thoughts or memories, and that's the calibration part. And so whenever you buy this device in 30 years, it wraps around like a headband or a sweatband, and you watch a 2-minute video, and then it's calibrated and ready.
Yes. It's the same thing that the emotive device trying to do. It tries to show you something. Instead of YouTube video, it shows that floating cube. And when I want to train the system to push it, it will actually push that floating cube, and then it will capture what actually brain waves I generate for that particular event.
Seems like a problem with this would be thinking, like, how you plan to do stuff before you do it. Like, how do you differentiate between that? So I think I'm driving a car, I'm going to turn left in 3 miles. So if I plan that right now,
yeah, that's. I have no answer for that actually. So what I'm right now, none of these technologies are perfect for like critical applications like driving a car. I wouldn't be using this, right? But for example, for Sean's case, turning a switch on, turning the heating on, that's not actually dangerous, right? Probably turning the heating on, probably it has a little bit of risk, but maybe turning the volume of the TV, volume or turning the TV on, something like that is actually very possible.
For me, it would be changing desktops. So like, if I'm thinking that's the program that I want to control, I no longer have to click that bar, and then it's just that's the one that pops up.
I'll show you a video. And it's actually really. I don't know if I have enough time. It's like the 2-minute video. Is it okay?
It's good.
Yeah. Let's go. What's that? Star Wars. The robot. Yeah, the ball.
Spock.
BB-8, right? BB-8 mind. Okay, let me connect to so this IBM engineer, he's working on this device. I think he's actually working on the advanced one of this, and he actually controls BB-8 using this device. That's really cool. See, it's not spinning.
Hit refresh.
No sound?
There's an audio jack right beside your laptop.
No, that's.
I can hear it, but.
No, that's.
Sorry for you guys. It's awesome.
What's it say?
Something about Star Trek and Spock. I don't know.
I expected it to be bigger though. How's that going to stop like a Imperial Stormtrooper?
Right. Ah, here it is.
Yeah.
Where do you plug this in?
I don't. Okay, I think it's this one.
Jedi mind helmet. You control his.
Oh, because it's coming out of the HDMI port, it's not going to work.
Do you want to turn off your HDMI?
No, because then we'll use the
Then video won't come on.
Do you want to turn off the HDMI?
Then how about the video? Video? Can we get the video without HDMI?
Yeah, I don't know where to do it on Windows. So the open source one, how much would it cost for the parts for that?
If you 3D print it, probably you can buy the sensors for $200, maybe maximum $300.
Ooh, it sounds like something fun for a hackathon.
Yeah, but
And
this.
how many sensor points did that have?
That has, I think, 8.
8.
Yeah.
To recognize certain familiar commands that we think. I'm a huge Star Wars fan, and I distinctly remember watching the Star Wars film where Yoda brings the X-Wing out of the water, and I spent probably far too long than I'd like to admit staring at cars to see if I could move them. So to have that ability to control my own The Force in this instance, that's very cool. My name is Joshua Carr, and I am the technical liaison for IBM's Worldwide Remix. I'm always curious about the technology that's coming up, what's next. And recently, the headset that allows consumers essentially to read their own brain and understand what's going on inside your head was successfully funded, and I had the opportunity to get hold of one of the first that was shipped. The headset itself uses known technologies to look for specific markers, things like excitement and interest. What we can do is train our headset to recognize certain familiar commands that we think, and the device learns essentially that this means action A. Then we can send that data via Bluetooth off to the internet. But once it's there, what do we do with the data? There's an awful lot going on in my brain, I hope, and what can we do with that? And that's where IBM technology comes in. We process that data, we flow it through, and we make meaningful interactions using small amounts of code. So in this instance, what I'm doing is using a command and translating that into a push movement. I used the Java SDK that came with the inside and the Java Internet of Things Foundation library, and essentially combine them together to publish the data to my Internet of Things service that sits on Bluemix. And I spun up a boilerplate that uses Node.js, and on top of that sits Node-RED, which is a wiring tool for the Internet of Things that allows you to easily and efficiently take data and run functions against it, sometimes with code and sometimes without having to explicitly write the code itself. In the films, they talk about the Force binding people together. In the near future, we're going to take a huge leap in feeling truly connected with other people. And for me, it was such an easy step to think about how can I use my brain to control robots around me. If I could make any technology from Star Wars real, it would not be lightsabers. Can you imagine giving a lightsaber to somebody? The first thing they would do is chop their arm off. Let's take baby steps. First, faster than light spaceships, and then lightsabers. Once we can prove that we're not going to destroy the universe with spaceships, then maybe we can deserve lightsabers.
Exactly.
So this guy is using the same device, but it's a different. That's the white one, but it's the same device. So he was talking about training the headset to train on different commands, right? So it's the same. He was using the same software that I showed you before. So yeah. So I'm really sorry with the other one. I mean, the other demo didn't work, but at least we got the IoT demo working. So I think that's it. Thank you very much, and I hope that I managed to generate some interest on this brainwave thing. It's really cool. Trust me, when you start doing it, you will see it's really interesting, and you will start thinking about a lot of things, how we can actually use this. All right, thank you.
So that's pretty much it for tonight. We don't have any swag, but the sign-up sheets that we passed around, where are they? Ah, sweet. Well, it's not too late to sign up. So if you guys, ooh, nice job, guys. I see a lot of names on these sheets. But please come see me or come sign up for all the cool things we got going on at Maker Faire and the Geek Fest. Thank you, guys.
What is the Internet of Things? Is it hardware, software, or both? Well, chances are you already have it in your pocket. It might be on your wrist. Recently popular are fitness bands with accelerometers and gyroscopes to monitor our activities and heart rate. Now we have smartwatches which do all of that, play music, and they can answer messages. Smartphones and tablets have replaced maps, secretaries, alarm clocks, entertainment, and now they can control our homes, change the TV, the temperature, security, and lights all from your device. Our cars are even getting smarter with sensors to keep us safe. The Internet of Things is simply using technology to mimic the human experience and simplify life.